Hello everyone, welcome back. And then today we're gonna continue with the tangent to and normal, which is chapter 10. Um, so this is the last one before the unit 3 finish. So start beginning with the tangents and normals. So this a very short chapters, and we can see it's 10A to 10F, but we're gonna go through everything we need to know as in the SAC. Um, so remember, you have to do some revision and pretty much like very closest to differential equations and stuff, the differentiations in the chapter 9. So we're straight to the example 1 and start with some questions like tangent to the curve. For example, we had a tangent to the curve y equal to x cubic plus half x squared. The point is x equal to 1. So when x equal to 1, y equal to 3.5, which is we can substitution in when x equal to 1, y equal to 1 plus half, which is 3 over 2. That's a point on the tangent. So this is a point on the tangent. So hopefully you understand this point on the tangent. Yeah, once you know that, and we can start with dy dx equals. So dy dx equal to 3x squared plus x. So this is the gradient of tangent when x equal to 1. dy dx equal to 4. The 4 are representing gradient. Representing gradient of the tangent. Yep. And this is very important. Now, does anybody remember y minus y1 equal to x minus x1? This is our tangent to the curve. So we're going to find the equation. So now we substitution 3 over 2 for y, and we substitution x equal to 1, and we substitution the gradient 4. So now we actually can rewrite our answer will be y minus 3 over 2 equal to 4x minus 1. So that equal to y equal 4x minus 4 plus 3 over 2. So y equal to 4x minus 5 over 2. Yep. So this is a tangent to the curve. So now I'm gonna try to start with normal to the curve equation. So same ideas, you get the points, and that's the on the normals. And then what we do is we do dy dx first. So dy dx equal to 3x squared minus 4x. And then when x equal to 1 and your gradient equal to 3 minus 4, so dy dx equal to 3 minus 4 equal to negative 1. So this is a gradient of the normal. Yep. So once you had that, and you could just substitution in again, y minus y1 equal to negative 1x minus x1. Yep. So that equal to y plus 1 equal to negative x plus 1. So y equal to wait, hold on a second. 1 minus 4x, yeah, but x equal to 1. Yeah, so that's your y equal to minus x, pretty much. Yeah, so once you have this one, what we do is actually, wait, did I miss something? Yeah, sorry. Actually, when forget about this. Okay, so once you had a gradient to the normal, so that's your gradient to the curve, the tangent to the curve, but not normal. The gradient of not normal. So which is we do is perpendicular. Okay, so we do perpendicular means uh that means like your gradient should be times, so 1 times m equal to -1, and that means m equal to 1. So this is your gradient to the normal. This is your gradient to the normal. Gradient to the normal. Sorry, guys. And then now we do y minus -1 equal to 1 x minus 1. That makes sense now. So y plus 1 equal to x minus 1. So y equal to x minus 2. Thank you. There you go. That's just a tangent to the normal. Thank you. Um, Sorry about that. And then now we can do this question with well, we can do this one in class. Um, so remember, you could find your tangent lines by CAS calculator as well. So I will show you during the class as well. So make sure follow these steps: menu, calculus, tangents, lines, and then you find the graph. So and also sometimes we can find some like cosine graph as well. So if you had y equal to negative cosine at a point that is negative pi, so we could do is we find the tangent to the normal. So um, the first thing first, we find dy dx equal to sine x. So x equal to pi over 2. So dy dx equal to 1. And so this is a gradient. And then now what we do is when 1 times m equal to -1, m equal to -1, this is your tangent to the normal. As I said, my mistake again. So y minus the 0 equal to -1 x minus pi on 2. So y equal to negative x plus pi on 2 is normal line. Okay. If you want to find tangent, so you just substitution the x equal to 1. Then. Yep. Hopefully that makes sense. And one last question. We could graphing this, but I want to do maybe just question A instead. Fx equal to x 1/3. So dy dx, let fx equal to y. So dy dx equal to 1/3 x negative 2/3. Yeah. So, and you can say we have the when x equal to 0, and then the f. So we can say fx. So fx f dash x equal to 0 as well. And then that's which is the line had a vertical tangent. So vertical tangent. So the graph looks like that. So hopefully that makes sense. It's like you're going from here. Oh, that's not good. Going from Jesus, going from here to here, so like that. So this is pretty much the question they're asking. Yeah. So if you have any questions, please let me know. And yeah, thanks for the listening, and we come back soon.